Alright, so in this video I'll be talking through page 25. This is kind of a variety of practice with inverse functions. So we're going to kind of build on all of the skills that we've looked at over the last couple days. So starting off with the first problem, you see we have this function g of x, and we want to find the inverse function. So for this we want to think about it as, if we can put it in the notation, y is equal to the square root of x plus 3. And we want to switch x and y. It means x is equal to the square root of y plus 3. Meaning x squared is equal to y plus 3. And y is equal to x squared minus 3. So that means if g of x is square root of x plus 3, then the inverse of that, g negative 1 of x, is x squared minus 3. And if we want to think about g negative 1 of 5, well, now we can evaluate that function at 5. So g negative 1 of 5 is equal to 5 squared minus 3. It's 25 minus 3, which is 22. Okay, moving on to this one over here. We want to find the inverse function here. We do y is equal to 4 over x minus 1. And I'm going to switch x and y. So that means we would have x is equal to 4 over y minus 1. And this can be a little bit tricky to work out of, but what I'm going to do, I'm going to multiply both sides by y minus 1. That way the y minus 1's over here cancel out. So then we have x times y minus 1 is equal to 4. We can divide both sides by x. And then we get y minus 1 is equal to 4 over x, which means y is going to be equal to 4 over x plus 1 when we add 1 to each side. That means if f of x is 4 over x minus 1, well then f negative 1 of x is equal to 4 over x plus 1. All right. And now we want to find the x-intercept for f negative 1 of x. So this is going to be where the function f negative 1 of x is equal to 0. So 0 is equal to 4 over x plus 1. And you can either do it this way, or you can plug it into your calculator and find the x-intercept that way. I'm just going to do it algebraically since it's right in front of me. That means negative 1 is equal to 4 over x. Negative x is equal to 4. Meaning x is equal to negative 4. So the x-intercept for this function is located at x equals negative 4. All right, and using the table here, so f of 3, so that means we're looking at f of x when x is 3, so f of 3 is 9. So f negative 1 of 7. So for this one we want to think about, we know when we input 2 into the original function f of x, we output 7. That means with the inverse function, if we input 7, we have to output the opposite. We have to output 2. And so g negative 1 of 2, we can see that when we input 3 in the regular function g of x, we output 2. That means when we output 2 in the inverse function, we have to input 3. Or we have to output 3. All right. And then for f negative 1 of x equals 3, here we're looking at what function, when inputted into the inverse function, will output 3. And if we look here, we can see that if we input 3 into the original function f of x, then we output 9. And that means if we input 9 into the inverse function, then we're going to output 3. So because f of 3 equals 9, f negative 1 of 9 has to equal 3. If we go down here, function f passes through the points negative 3, 7, 0, 4, and 2, negative 6. State 3 points which lie on the inverse function f negative 1. So we know that if we have a function that passes through the point a, b, in other words, when you input b, you input a, you output b, then the inverse function has the point ba, right? If you input b in the inverse, you have to output a. So that means for each of these, we can simply switch x and y, right? We can switch the domain and range, and we saw that algebraically. So that means the 3 points on the inverse function are going to be 7, 3, 4, 0, and negative 2, 6. And now drawing the inverse function, remember that that means that we're flipping it over the line y equals x. So if you imagine the line y equals x here, and if we flip it over that line, it's still going to be sinusoidal. It's just going to have kind of the opposite, like we're going to be phase shifted a little bit. So your inverse is going to end up looking something like that.